Assalamualaikum everyone. Welcome to the electron beam lithography lecture. So here's the content of the lecture today. So electron beam lithography, usually abbreviated as E-beam lithography, or we can also call EBL. So EBL is the practice of scanning a focused beam of electron to draw custom shape on the surface covered with an electron sensitive film called a resist. So the process more or less is quite the same like the photolithography and also X-ray photolithography. So electron beam lithography is a maskless technology compared to the X-ray and also photolithography. Electron beam lithography does not require mask. The final pattern is created directly from a digital representation on computer, meaning that after the design, it can be printed directly on the substrate. So there are three source of electron beam. One is thermionic emitter. So thermionic emitter is electron is released due to the thermal energy, and photoemitter due to the incident radiation, which is photons, and the field emitter due to the applied current and quantum mechanical properties of the electron. So let's see the procedure of the EBL. So for the first one, the sample is coated with a thin layer of resist, which is PMMA, the same with the X-ray lithography. So exposure of electron on the PMMA, it will break down the PMMA into monomer upon exposure to the electron. So after that, it goes to the development process, and then deposit of the active golden layer. For 1 hour, this layer is around more or less is 100 nanometer. So the exposed region can be rinsed away, so meaning that it's in the developing process using a chemical called MIBK, or methyl isobutyl ketone. So the removal of remaining resist is by dissolution in an organic solvent, for example acetone. After that, sample was washed in acetone, IPA, deionized water, and blew off by compressed nitrogen. So that's the summary of the procedure. So this is the illustration on the process for you to understand better. This is showing the example of the E-beam pattern after the process finish. So if you can see, the the shape is very sharp, okay, very accurate. So that's the advantage of the EBL. So now let's see the spectrum of the electron beam. So if we already see in the previous one on the UV and also the X-ray, so electron beam is the wavelength is shorter compared to the X-ray. So then it can be smaller, so you can produce the parts also into a smaller part. Okay, so that's why electron beam lithography is popular in the nanotechnology process. Let us look into the EBL component. So EBL component consists of the electron gun, beam blanker, deflection coils and lenses, vacuum chamber, resist, film, substrate, and also table at the end. Okay, so the deflection coil and lens is used to focus the electron, where beam blanker is turning the beam on and off. So then stick metal is a special type of lens used to compensate for imperfection in the construction and alignment of the BL column. So then vacuum environment is needed in order to isolate the electron beam from the interference. So let's see the video on the EBL later. The picture shows how the pattern is exposed on the substrate. So the side view is the schematic diagram, and the top view is showing how the exposed pattern look like. Okay. Electron beam lithography usually used primarily for two purposes. One is for very high resolution lithography, for example, nanoscale parts or fabrication of mask. EBL have their own advantages and also disadvantages. In terms of the advantages, it can print complex pattern direct on wafer without the mask, so you don't have to fabricate the mask first before the printing on the wafer. It can also eliminate the diffraction problem that have in the X-ray lithography and also photolithography. It has also high resolution up to 20 nanometer and flexible techniques. However, the disadvantages will be it's slower than the optical lithography and more expensive and complicated. Then forward scattering and back scattering problem because of the secondary electrons. So this one we will see. There are a lot of non-ideal effects of electron beam lithography. However, in this class, I'm going to show two non-ideal effects of the E-beam lithography so that you can see some error that might happen in the E-beam lithography process. Stitching is one of the problem in the EBL. So if you can see from the picture from at the left, you will see that the perfect printing will have no stitching error. So second, it goes to shear error caused by the field rotation. So and then underexposure or gap caused by the field sizing error, and another one is overexposure or bulk caused by the field sizing error. So if you can see on the right, this is the SEM picture showing the horizontal stitching problem. So if you can see, the line that's supposed to be straight is not straight, so this one is example of the stitching problem. There are a lot more stitching problems, so you can search and see how the stitching varies from one to another project. So another error that can happen in the EBL is proximity effect. So proximity effect is usually due to the electron beam scatters when interacting with the substrate and resist material. From the picture, if you can see, the first one, electron is projected, okay, and then it's supposed to create holes, okay, in between this one, but instead of a straight part, okay, so it's straight holes. What happened is the electrons scatter like in the right picture, so then it create like a proximity effect on the material. So this picture shows how the backscattering happens. So due to the secondary electron, so when the electron meet the resist, there is secondary electron that's scattered under the resist and then touch the substrate, causing the error in the surface of the substrate. So this one will cause the proximity problem. Here's the video link. So this video link is the same like I've already put inside the Google Classroom. So you can look into this one if you want to refer it back later. So that's the end of electron beam lithography. See you in the next class. Assalamualaikum. Thank you for listening.